All right, the next thing we're going to do is combinations. Remember, we did permutations, now we're going to do combinations. So here, suppose an art museum owns 8 paintings by a given artist, and another art museum wishes to borrow 3 of these paintings for a special show. Now, in selecting 3 of those 8 paintings for shipment, the order wouldn't actually matter. And we could simply select 3 element subset from those 8 paintings, and that's going to be called a combination of the 8 objects taken 3 at a time because it doesn't matter what order you choose them. You could choose, if they were 8 different paintings, you could choose this one, and then that one, or you could choose this one, this one, this one. It doesn't matter. You're getting 3 paintings no matter what. Now, this is a combination of n objects taken r at a time. Now, with a combination of n objects taken r at a time without repetition, so again, without repetition is again the key thing, we can have R element subset of the n objects. Now, the arrangement of the elements in a subset doesn't matter. So order doesn't matter. So you could choose this one first, then this one, and then this one, or you could choose this one first, and then this one, and then this one. It doesn't matter order, okay? So that's going to be the key. Order does not matter. So that's how you tell the difference between a combination and a permutation. Now, why do they call it a combination lock? I'm not sure because order really matters on a combination lock. All right, so the number of combinations of n objects taken r at a time can be kind of represented in a whole bunch of different ways. And so NCR is going to be the key for this one. Remember, we did NPR for permutations. Now we're doing NCR. And so 52C5 is going to look like that if we put it to the form here. Basically, if we look at combinations, it's the number of permutations divided by r factorial. So that's going to be the key. We could find the number of permutations and then we divide by r factorial, and that would give us the value. Or we could just plug it in n factorial divided by r factorial times n minus r factorial, and that would give us this. And again, we could just use our calculator and use that function and it will give us the answer as well. So lots of different ways to represent it. It all depends on what kind of representation they're actually asking for in the book. So from a committee of 12 people, so our total is going to be 12, how many ways can we choose a chairperson, a vice chairperson, a secretary, and a treasurer, assuming one person cannot hold more than one office? All right. So thinking about that, what does that mean? Well, does order matter in this one? Okay. So that's what our first key always is, no matter what the problem, because they could put this in any order in the book or on the test or things like that. So does order matter? Well, if you're going to have a chairperson, a vice chairperson, a secretary, and a treasurer, order really does matter here because, you're not going to put the treasurer in the chairperson's place and you're not going to put the vice chair as the secretary. The chairperson is the chairperson, that is that. And so we're going to say there are how many ways to do that one? Well, there's going to be 12 ways to choose the chairperson. From there, there's only 11 ways to choose the vice, 10 ways to choose a secretary, and 9 ways to choose a treasurer. So what is that? Well, that's also equal to 12P4. And if we multiply those all out, that's going to be 11,880. Okay. So this one, order does matter. Okay, so that's the key. So that's why we can do 12 times 11 times 10 times 9 or 12p4 and we get 11,880. Now, this one just says how many ways can we choose a subcommittee of 4 people? Now, does order matter? No, because it's any 4 people on the committee. So this is A. Now, B, we can choose any 4 people. So order here, that's O-E-S matter. Does not matter. Okay, so order here doesn't matter. So with that then, that means we're going to do 12C4. Okay, well, 12C4, let's go over and look at our calculator and see what 12C4 is. So we're going to do math, arrow over to probability. We're doing number 3 this time, and we're going to do 12 and 4, and we get 495. And again, it works just the same as permutations as far as typing it in the calculator. You put your N and then your R, and you get your values out there. So coming back over here, we get 495. Okay. All right, so let's pause there and we'll come back for some more.